I now want to define the definite integral of a function y equals f of x. So I'm going to define it as the area under the curve. So the definite integral from a to b will be the area under the curve of the function y equals f of x. The vertical lines, x equals a and x equals b, and the x-axis, so the area under here. So how do we do that? Well, we draw this infinitesimal rectangle inside of our domain. It has a width dx and a height f of x, and it's at the point x. So we have our infinitesimal area, which is the area of this rectangle, is equal to the height times the width. So it's equal to f of x dx. So that will be our differential of the area. And we're going to define the definite integral then as the sum of all of these infinitesimal rectangles. That will give us the area. And the symbol we'll use for the integral is this large S-shaped symbol. And we're integrating dA. And the way we'll write the definite integral then is this integral symbol. So we'll say the integral from a to b of f of x dx. Okay? So let me say that again. The area then under the curve is the integral from a to b of f of x dx. A and b are called the limits of the integral. A is the lower limit, b is the upper limit, and f of x is called the integrand. This x here turns out to be what's called a dummy variable. All it tells us is the dx tells us we have to integrate the variable x. But we could also simply write that as another variable here. So we could write that as f of s ds. You can put any variable you want here as long as you match the variable of the function with this d variable. So x dx or s ds, perfectly fine. Okay, that's our definition of the integral. It doesn't tell us how to do it. We'll have to refer that to later lectures. But now let's extend this definition a little bit further. This is a definition from the area under the curve, but we can extend the definition. We can extend it by, instead of integrating from a to b, we can ask what is the integral from b to a of f of x dx. We're going to define that as the negative of the integral from a to b of f of x dx. Okay, so if you switch the order of the integration limits, you can switch back by introducing a minus sign. The other extension is what happens if we want to integrate a function which is negative. So let me just say negative f of x dx. So let's say f is a positive function like this, but we want to integrate it if it's negative, so it's below the x-axis. The way we do that is we say that all the area that's below the x-axis counts as negative area. So that would be the negative of the integral of a to b of this positive function f of x dx. So above the x-axis is positive area, below the x-axis is negative area. Another useful relationship is if we have a, b, if we also have a point, say, c here, and we wanted to know what was the integral from a to c of f of x dx. Well, the area under the curve from a to c is equal to the area under the curve from a to b plus the area under the curve from b to c. So we can write that as the integral from a to b of f of x dx plus the integral from b to c of f of x dx. So sometimes the splitting of an integral into two integrals can save us some work in evaluating the integral. Okay, there's one more point I want to make here, and that's special types of functions. So let's, for example, say f is an even function. What does an even function mean? It means that f of negative x equals f of x. What does that function look like? Well, that's the function that looks like a quadratic, say. So it looks something like this. So if we're integrating an even function from a symmetric interval, so from minus a to a of f of x dx, it's the same integral from minus a to 0 as from 0 to a, because the function is even. So this is equal to twice the integral from 0 to a of f of x dx. So sometimes we make use of this simplification. The other case would be if f is an odd function. In that case, f of negative x is equal to negative f of x. And the typical picture of that type of function would be something like x cubed. So it could look something like that. Now, if we integrate from minus a to a of an odd function f of x, then on the left side of 0, we would have negative area for this particular graph. On the right side of 0, we would have positive area. They would both cancel, so this integral would just be 0. So the integral symmetric about the origin of an odd function is 0. That's also sometimes a very useful simplification. So let me summarize. I'm explaining the definition now of a definite integral. We defined it as adding up all of these infinitesimal rectangles under the curve. We can write one infinitesimal rectangle as a dA equals f of x dx. And then the area we write as this integral, the big S symbol, dA. And we say it's the integral from a to b of f of x dx. Then we extend that definition to the case instead of from a to b, we have b to a, changes the sign of the integral. Or if the curve is below the x-axis, it counts as negative area. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.